This call is now being recorded.
Teaser sir, screenshot తీసుకోండి సార్.
ఓకే సార్, ఓకే సార్.
సార్ బిగిన్ చేయండి సార్, టీజర్ సార్.
ఓకే సార్, ఓకే, థ్యాంక్ యూ.
Sir, good evening to all participants, and I welcome to today's faculty lecture series. And today's resource person for the today's session is Sri Ramakrishna Reddy sir, Associate Professor from Mechanical Engineering Department. Welcome you, sir. And I request you to please start the session, sir.
Okay, thank you, sir. So, good afternoon, everybody, to my dear colleagues and students. I am Ramakrishna Reddy, Associate Professor, Mechanical Engineering Department, and as a part of lecture series organized by CRI department of our college, today I got opportunity to deliver my lecture. And thanks for giving me this opportunity. Thanks to the management and director sir and principal sir and CRI Dean M.V. Narayan sir and Keezer sir for giving me this opportunity. So usually everybody is say curious about how aircraft engine works. So that's why I have selected a topic, jet propulsion systems, today. In this topic, I try to explain different types of aircraft engines, working principles, and their constructional details. Let me start. So jet propulsion systems. So how does an aeroplane fly? What are the various forces acting on the aeroplane? Usually there are four forces, like thrust. The main force is thrust, and next lift, and drag, and gravity. So what is meant by thrust? It is a force with which the plane is moving in the forward direction. Then what is lift? It is a force which lifts the plane in the upward direction. That is called lift force. Drag means it is the air resistance acting on the plane, which opposes the airplane movement. Then gravity means everybody knows that is the gravitational pull. So then how the thrust actually generates? With the main force is only thrust, so with which the aircraft is moving in the forward direction. So here the main forces are thrust and lift only. Then how the thrust generates? Thrust may be developed by two methods. One is by jet propulsion principle, and second one is by air screw principle. Then what is jet propulsion principle? A fast moving jet that is discharged from the aircraft generates thrust by jet propulsion in accordance with the Newton's laws of motion. Then everybody knows in childhood we have studied Newton's laws, 3 laws. Then according to the second law of Newton, the rate of change in momentum is proportional to force. This everybody knows. Then similarly, according to Newton's third law, for every action there is an equal and opposite reaction. Based on these two laws only, actually the thrust in the airplane develops. So then what are the active and reactive forces? When the air is entering into the aircraft with entry momentum, and the gas leaves the aircraft through nozzle with increased momentum, this change in momentum produces jet force. This actually happens according to the Newton's second law. So this force is actually developed in the backward direction of the aircraft movement. So this jet force is active force, and we treat this jet force as active force. And as a reaction to this, a force equal in magnitude and opposite in direction, that is in the forward direction, acts on the jet issuing body. What is a jet issuing body? It is the engine structure. So this happens according to the Newton's third law, because for every action there will be equal and opposite reaction. So this reactive force only is called is the driving thrust moving the vehicle in the forward direction. This principle is used both in the jet and rocket engines, and also in the rocket engines. This is jet propulsion principle. Then what is the air screw principle? Then second method is air screw principle. Then air screw principle can be explained with the two examples. Here I am considering two examples. Let me explain the first one, first example. If a screw is to be fixed on a wall, what actually we do? The screw head is to be rotated with the help of a screwdriver. Thus the screw gets linear motion and the screw penetrated into the wall. This is actually called a screw principle. If you want to unscrew, then we rotate the screw head in the anti-clockwise direction. Then the screw actually comes out from the wall. So that means if you give rotary motion to the head, then the screw body gets the linear motion as output. If you give linear motion as input, then the screw head gets rotary motion as output, vice versa. So let me take the second example. This is everybody's experience. What we do in childhood days, we played with a paper fan attached to a stick with the help of a thorn. So if you just hold the fan and stand, it won't rotate. Then, but if you run, then the fan rotates. That means if you give linear motion as input, then the fan rotates. In the opposite sense, if you speak in the opposite sense, somehow if you make the fan to rotate, then the fan holding body gets a linear motion as output. So the aircraft needs a propeller or a fan to generate thrust or force through this principle. That means we need to actually run the propeller with somehow we need to run the propeller or a fan. Then automatically the propeller holding body, that is aircraft engine, so we'll get the linear motion. Linear motion in the forward motion. So that is the air screw principle. So with these two methods, actually the required thrust will be generated in the aircraft. Then coming to the second force, that is the lift force. Then how the lift force is generated? Then how does the lift force is generated based on the Bernoulli's principle. This is also Bernoulli's principle, also a well-known principle. How does Bernoulli's principle generate lift? So Bernoulli's principle, which says that if airspeed increases, then automatically the pressure decreases. So lift is achieved by the design of an airplane wing. The wing is made with an aerofoil shape. That means the top portion of the wing is curved shape and the bottom portion is flat. So air moves over the curved portion very quickly than it does under the wing. So which has a flatter surface. So obviously the fast moving air produces less pressure on the top portion and low pressure, high pressure on the bottom portion. So this pressure, due to this pressure difference, so obviously the aircraft tries to move from the high pressure to low pressure side. So that means in the upward direction. In that way, actually the lift force is generated. So the aircraft actually gets lift in this way based on the Bernoulli's principle. So then coming to the history of jet engines, the first jet engine was built by the Egyptian scientists during 100 BC. It's a age-old this one development. But this device was actually known as aeropile. But the jet propulsion only took off with the invention of gunpowder-powered rocket by the Chinese in the 13th century. So this is the brief history of the jet engines. Then coming to the different types of jet engines. So today we are using turbojet engines, turbofan engines, turboprop engines, ramjet engines, and rocket engines in the jet propulsion systems. The above first four are actually used for aircraft engines, and the rocket engine is used for the rocket space propulsion. The first four engines actually are called air breathing engines, and the last one, rocket engine, is called non-air breathing engine. Why means, so for combustion purpose, actually the oxygen is required. Then oxygen is taken from the air. So the first four engines actually takes the required air from the atmosphere. But the rocket engines usually operates beyond the atmosphere. So that's why both the oxidizer, the required oxygen, and also the fuel will be carried along with the rocket engine within the rocket. So that's why rocket engine is named as non-air breathing engine, because it is not breathing engine from the outside atmosphere, right? Then next, coming to the first one, turbojet engine. So what are the different parts of turbojet engine? Then what is the working procedure of turbojet engine? So the different parts are diffuser and rotary compressor, then combustion chamber, it is also called burner, then gas turbine and gas nozzle. These are the main parts of the turbojet engine. So what are the functions of each one? Diffuser, compressor, combustion chamber, gas turbine, and gas nozzle. So before going to see this, the working of the function of each component, let us see these energy conversion principles. So here I'm just giving the short forms. KE means it is a kinetic energy, ME means mechanical energy, and PE means pressure energy. Here actually I have given, and HE means heat energy. Again KE and ME, kinetic energy and mechanical energy. And so here the kinetic energy is converted into pressure energy with the help of a diffuser, and the mechanical energy is also converted into pressure energy with the help of compressor. And this pressure energy is converted into heat energy with the help of a combustor, that is combustion chamber. And this heat energy is converted into mechanical energy with the help of gas turbine. And heat energy is converted into kinetic energy with the help of a device called nozzle. So now let us see, you will clearly understand. So the diffuser raises the pressure of air by converting the kinetic energy into pressure energy. So compressor, it raises the pressure of air further by converting mechanical energy into pressure energy. So the function of both diffuser and compressor is same. It is to raise the pressure of air only. But the energy conversion principle is different. Diffuser converts kinetic energy into pressure energy, whereas compressor converts mechanical energy into pressure energy. So ultimately, we need the air pressure is to be raised. So then next, combustion chamber. So this pressurized air now enters into the combustion chamber, and actually the fuel is being injected into the combustion chamber, and so the fuel is mixed with the air, and then with the help of igniter, the fuel and the charge will be ignited, and combustion takes place. So the hot combustible gases are produced. So that means heat energy is developed in the combustion chamber. So next, gas turbine. So this heat energy is converted into mechanical energy with the help of gas turbine. So the part expansion of hot gases takes place over the rotor blades of the turbine, and power is produced by the gas turbine. Then what for this power, gas turbine power is used? It is exclusively used only to just run the compressor, because diffuser, maybe it is not a power, work absorbing machine, component. But compressor is a work absorbing machine. So that means compressor needs work input. So whereas a diffuser, it is actually a duct, varying area duct. So just it converts kinetic energy into pressure energy, but compressor converts mechanical energy into pressure energy. So that means compressor needs mechanical energy. So that mechanical energy is given by the gas turbine here. So the role of gas turbine is to run the compressor. Then next, gas nozzle. So the hot gases are now passed through the nozzle. Then after passing over the gas turbine, the remaining expansion of the hot gases taking place in the gas nozzle. This gas nozzle converts heat energy into kinetic energy, and the high velocity gas jet is discharged from the aircraft, and thus thrust is produced according to the jet principle. Already we discussed how the thrust is generated by jet propulsion principle. That actually follows the Newton's second law of motion, Newton's second law and third law. So that is jet propulsion principle. So based on that, so here actually the thrust is nozzle thrust or the jet thrust is developed, which makes the aircraft to move in the forward direction. So this is actually shape of the jet engine. So this is actually the core engine. This is the compressor rotors, and this shape. So this diverging shape is a diffuser, and this area is burner. That means combustion chamber, and this is a single rotor turbine, and this converging shape is a nozzle. Both the diffuser and nozzle are actually varying cross-sectional areas only. Diffuser is diverging and the nozzle is a converging area. Of course, there are different types of nozzles and diffusers. So it is immaterial now. Just at present, diffuser means diverging area and nozzle means converging area. We take in that sense. So here, see, the turbine and the compressor rotors are connected with the rotor, with the shaft. So with the shaft, actually the turbine runs the compressor. So air actually enters in this direction, and so part pressure rise taking place by the diffuser, and the remaining part pressure rise taking place by the compressor. And the high pressurized air enters into the burner, that is the combustion chamber, and here fuel is being injected, and here ignition takes place, and hot combustible gases are produced here, and those hot combustible gases are passed over the rotor of the gas turbine and produces work, and this work is transferred to the compressor, and the gases are now passed through the nozzle where further expansion takes place. So that means conversion of heat energy into kinetic energy. So that means the hot jet, jet with high velocity is now exhausted from the aeroplane. So air actually enters with less kinetic energy, and gas now leaves the aircraft with high kinetic energy. So due to this change in the kinetic energy, obviously it results in the change in the momentum. So the rate of change of momentum is only nothing but the force. So that is called thrust according to Newton's second law. So that means this high velocity jet produces jet force in the backward direction. According to Newton's third law, that jet force is actually applied in the opposite direction. That means the jet issuing body means it is the engine, core engine. So that reactive force is actually applied on the aircraft engine. So in the forward direction, that makes the aircraft to move in the forward direction. So this is actually a realistic picture of this one turbojet engine. These are the rotors and compressor rotors, and this is the shaft, and these are the rotors of the gas turbine. So and this area is the combustion chamber, and this is the gas nozzle. This is the gas nozzle. And next is turbofan engine. Second type engine is turbofan engine. So turbofan engine is nothing but it's a slight modification of turbojet engine. It's a turbojet engine only, almost slightly modified by adding a large frontal fan. The remaining parts are similar to turbojet engine. So remaining diffuser, compressor, and then combustor, and the gas turbine, and nozzle, etc. are actually remained here even in the turbofan engine also. In addition to those say parts, that an extra large frontal fan is actually attached to the turbojet engine. So that is a turbofan engine. So what is the role of a fan means? Fan acts like a propeller here and also as a low pressure compressor and handles large volumes of air. See, this is the actually picture of the this one turbofan engine. This is the main core engine. Similar to the turbojet engine. And this is the fan. And this fan is actually run by the compressor, turbine. So here the role of turbine is to run both the compressor rotors and also the fan. So air actually is divided into two streams here. One is main primary air and the secondary air. And the secondary air actually bypasses the core engine, and that's why that is called bypass air. And here actually it goes in this direction. So this is the outer casing of the engine, and through this actually the bypass air goes, and the primary air enters into the main core engine, and whatever the process happens in the turbojet engine, the same process occurs in the main core engine here also. Same compression, and then after that combustion. So hot gases are produced, and those hot gases are now expanded in the turbine and produces work, and the remaining part expansion takes place in the nozzle, which develops a high velocity jet, which is exhausted from the aircraft engine. And here the thrust actually is developed in two ways. One is the jet thrust as usual, so explained earlier, and the second one is fan thrust. So fan is also actually acting as a low pressure say compressor here. So that means the secondary air is also get compressed with the help of fan, and that compressed air now is discharged through this nozzle shaped outer casing, and again actually some extra thrust is provided here. So that extra thrust is added to the main thrust that is produced by the core engine. So that is the advantage of the turbofan engine. So this is actually a realistic picture of the turbofan engine. This is the fan, and primary air stream enters like this, and this is the fan stream bypasses the main core engine, that is called bypass air, and these are the compressor rotors looking like this, and these are also second stage compressor rotors, and this is the combustor. This one and this one are the combustors, and these are the turbine rotors, and the end one is the nozzle. So it looks like this. So the same picture, and when the aircraft engine is attached to the aircraft, it looks like this. This is the main engine, turbofan engine. So actually we actually divide this types of turbofan engines into two types: low bypass turbofan engines and high bypass turbofan engines. What is meant by low bypass turbofans and high bypass turbofans means, so actually thrust is developed by two ways here, I told. So one is fan thrust and the second one is jet thrust. If the engines use more jet thrust relative to the fan thrust, they are called low bypass engines. So that means primary is more than the bypass air. Bypass air is low quantity and primary air quantity is more. So those engines are called low bypass turbojets. And high bypass turbojets means less air enters into the core engine and more air actually bypasses the core engine. So they are called high bypass turbofans. So what is the actually difference between these two means? High bypass engine actually produces low noise, whereas low bypass engine actually produces more noise. So that's why low bypass engines are used for military applications, whereas high bypass engine turbofans are used for commercial aviation purpose. So the reason is jet thrust is more. When we are getting the thrust through jet nozzle, the nozzle sound is more. So that's why in the case of high bypass engine, jet thrust is less and fan thrust is more. Whereas in the case of low bypass engines, the jet thrust is more and the fan thrust is less. So when the jet thrust is more, obviously the sound is more, engine sound. So that is an audible sound, which is inconvenient to the passengers. So that's why they are not suitable for the commercial aviation. So they are actually well suitable for the military aircrafts. So because of the large frontal fan, the turbofan is more efficient than the turbojet. So the fan actually handles large volumes of air. So large volumes of air means the more mass of air enters into the engine. So the thrust is actually proportional. Here I have not given the thrust equation. The thrust is proportional to the air quantity, mass of air. More is the mass, more would be the thrust. So the fan actually handles more volume of air means more quantity of air. So that's why the thrust generated by the turbofan is usually more than the thrust generated by the turbojet engine. So that's why we generally treat turbofan is more efficient than turbojet engine. So because of lower exhaust speeds, the noise level is greatly reduced with the turbofan. So that is in the high bypass engines. But there is one disadvantage also. So the large inlet fan creates a large frontal area, which negatively affects the drag because usually drag is the main actually disadvantage with the aircraft engines. If the aircraft body frontal portion is in a blunt shape, then air drag will be more. So that means opposing force will be more. So that's why usually the aircraft nose shapes are actually made as a conical shape. Aerodynamic shape means a conical shape. Why means to reduce the air drag. So here in this one turbofan engine, there is a disadvantage. The fan actually occupies a large volume, large frontal area. So that is one disadvantage with the the turbofan engine. So most effective at speeds below the supersonic speeds. That means below the sound speed. That is 1200 kilometers per hour. Below that speed, these are actually most efficient engines. Next type of engine is turboprop engine. So the turboprop engine is also similar to the turbojet engine. The extra one is a propeller is attached to this, the turbojet. A turboprop is essentially a turbojet engine that is attached to a propeller. So turbine runs both the compressor and propeller. And thrust is developed here also in two ways. Thrust developed with the propeller, that is the air screw principle, as I told in the beginning. And next is jet thrust by the jet propulsion principle. So turboprop engine is more efficient at low speeds than a turbofan or a turbojet engine. So let us have a look at the figure of the turboprop engine. This is the arrangement of the turboprop. And this is the frontal propeller. And these are the rotors of the compressors. And these are the actually rotors of the second stage compressors. And these are the combustion chambers and rotors of the gas turbine. And this is the nozzle. So this compressor and the combustion chamber, gas turbine and nozzle are common in a turbojet, turbofan, and also in turboprop engine. So in turbojet, we don't have the frontal fan or the propeller. In turbofan, we have frontal fan. In turboprop engine, we have a propeller. So the difference between a propeller and a fan is having a number of blades, whereas a propeller is having only two blades. So propeller is actually produces a propeller thrust, that is the air screw principle, with the help of air screw principle. So the required thrust is actually generated here by two ways. One is jet thrust and the second one is propeller thrust. Jet thrust is based on the jet propulsion principle and propeller thrust is based on the air screw principle. principle. So this is the more realistic picture of the say turbofan engine. So this is the real picture of the aircraft engine, turboprop aircraft engine. So this is the diagram, and this is the two blade say propeller, and this is a gear arrangement because here turbine runs both the compressor and also the fan, propeller. So the turbine speed is different, and compressor speed is different, and fan propeller speed is different. So to have different speeds, we actually arrange all these things through gearing system. So this is actually called reduction gear. Reduction gear. So these are the rotors of the compressor, and this is the combustion chamber area, and this is the turbine rotors, and this is the nozzle. This is the nozzle. And propeller engines are most efficient at low speeds and used on large cargo planes. So here we are not discussing the performance. So if you want to say see the difference of performances of different engines, we need to say explain this with cycle diagrams and also the equations. That is not possible, and it's also not appropriate place this is. So that's why I'm not taking the performance analysis here. So I'm just giving the output data. So propeller engines are most efficient at low speeds and used on large cargo planes, and they produce greater power than comparable the piston engines. So aircraft engine also uses reciprocating piston engine also, radial engines and V engines, but very small size engines. So the propeller engines actually produces power greater than say the piston engines, and more expensive than piston engine, but it is. But propeller engines are actually used for medium size aircrafts, and turbofans and turbojets are used for heavy size aircrafts. Then next, and last type of aircraft engine is ramjet engine. So the main parts are here: diffuser, combustion chamber, and nozzle only. There is no compressor here, and there is no gas turbine. Only diffuser, combustion chamber, and nozzle. That's all. Diffuser is for pressure rise, to convert pressure energy into kinetic energy into pressure energy, and combustion chamber is to convert pressure energy into heat energy, and the nozzle is to convert heat energy into kinetic energy. That's all. And these are used extremely for high speeds. That means supersonic speeds. So the minimum speed is 400 miles per hour. So the ramjet engines used, the minimum speed is 400 miles per hour. So these engines does not contain any moving parts at all. So that means no compressor, no turbine, no reed valves. So the entire pressure rise depends upon the inertia of the incoming air. So that's why this type of pressure is called ramming pressure, ramming effect. So that's why these engines are named as ramjet engines. Ramming means the pushing effect. So pressure rise is achieved in that way. So the shape looks like this. So this is the diffuser section, and this is the combustion chamber section, and this is the nozzle section. So there is no rotating part at all, no compressor rotors and no gas turbine rotors. When there is no compressor, there is no need of gas turbine, because gas turbines are used only to run the compressor, and also suppose if there is a frontal fan or a propeller, it has to run that also. But here there is no frontal fan, there is no propeller, and there is no compressor. So that's why we don't need any gas turbine here. So for pressure rise purpose, we use the this one diffuser, and for heat addition we use the combustion chamber, and for converting the kinetic energy, heat energy into kinetic energy, we use the nozzle. So only used extremely high speed applications, so only military applications we use these ramjet engines. So but the major disadvantage with this engine is it is not of self-starting type, because here how the actually pressure rise takes place when the aircraft traveling with say 1000 kilometers per hour speed, then the opposite wind also airspeed is also 1000 kilometers per hour, and with that speed air enters into the say diffuser section. So that the air with 1000 kilometers per hour speed is having very high kinetic energy, and that high kinetic energy is converted into say pressure energy with the help of diffuser. But initially how to start the engine? So to rise the pressure, so we need actually kinetic energy. So without starting, how do we get the kinetic energy? So that means the starting problem. Ramjet engines are actually main problem with ramjet engines is starting problem only. So that's why along with the ramjet engines, always a small size turbojet engine is equipped. So the role of the small size turbojet engine is to take the aircraft to certain flight speed. Then after that, the ramjet engine comes into picture. So this is the realistic picture of the ramjet engine. Generally, these are used for the military applications, and also for the missile applications also. And next is helicopter engine. So helicopter engine is also almost similar to the aircraft engine. So the difference is, so here first let us see the helicopter working. Helicopter actually gets the lift with the top. There are two rotors here, top rotor and side tail rotor. Helicopter gets lift with the top rotor according to the Bernoulli's principle, same principle. So to get the forward motion, the top rotors are slightly bent forward. So that means by changing the pitch of the blades, that is called pitch changing. So that the horizontal component of, because with the Bernoulli's principle, we get the lift in the upward direction. If you say bend the top rotors, automatically we get the horizontal component of the lift force. So that horizontal component of the lift force becomes the thrust for the helicopter, which moves the helicopter in the forward direction. What is the purpose of tail rotor means? To keep the helicopter in balance, to compensate the unbalance created by the top rotor. So when the top rotor is rotating, obviously the entire body tries to rotate. The entire helicopter body tries to spin around the vertical axis. So to avoid that, we use the tail rotor. Tail rotor actually keeps that in balance. So one more purpose of tail rotor is to steer the chopper. That chopper means helicopter about the vertical axis. If you want to turn the helicopter, steering means turning. If you want to turn the helicopter, we need the tilt the tail rotor about the vertical axis. Then automatically the helicopter gets the turning action. So this is the picture of this is the cross section of the helicopter engine, and this is the schematic diagram. And here, as usual, compressor and combustors, and here gas turbine, power turbine. This is, and a nozzle here. And the gas turbine actually runs both the compressor and also the top rotor through gear, because top rotor rotates in the horizontal direction. And so that's why through gearbox, actually, the top rotor is rotated with the help of gas turbine. And tail rotor is also run by the gas turbine. So this is the helicopter engine working. And so the major advantage of helicopter over the aircraft engine is helicopters requires no runway, because aircraft to get sufficient lift, the aircraft has to run for certain distance up to attainment of certain velocity. Then only actually the aircraft gets the lift. So that's why it needs runway. But helicopter actually doesn't need any runway. So directly, just by rotating the top rotor, automatically it gets the lift. So the helicopter can actually, the main advantage of helicopter is it can move forward, and also it can move backward, and also it can remain in the air in the suspended state. So that is called hover in the air. So that advantage is there with the helicopters. So that's why helicopters are actually used mainly for military applications and for rescue operations, etc. Next is rocket engines. These are totally different. Rocket engines are actually non-breathing, air-breathing engines. They are actually classified. Here there are so many classifications of rocket engines, and here I am considering only two types: solid propellant rockets and liquid propellant rockets only. And there are hybrid rockets, monopropellant rockets, and electric rockets, ion rockets, then solar rockets, then etc. There are fission rockets, etc. But here I am considering only two types: solid propellant rockets and liquid propellant rockets. So propellant means nothing but the mix of fuel and oxidizer. So fuel for burning and oxidizer is for combustion purpose. So because oxygen is not available in the space, so that's why the rocket engines carry oxidizer tank and also fuel tank along with it. So the oxidizer and the fuel put together is called propellant. If the both oxidizer and fuel are in solid form, those rocket engines are called solid propellant rocket engines. If the oxidizer and this fuel both are in liquid form, they are called liquid propellant rocket engines. And these liquid propellant rocket engines are again classified as pressure feed rockets and pump feed rockets. And this is the shape of this one solid rocket engine. This is outer casing, and this is the actually solid rocket. fuel, and this is delay charge, and this is the ejection charge, and this is the nozzle. And how it works, let us see. In solid rocket, the propellants are mixed together and packed into a solid cylinder. Under normal temperature conditions, the propellants do not burn, but they will burn when exposed to a source of heat provided by an igniter. Once the burning starts, it proceeds until all the propellant is exhausted. We cannot stop it. So with a solid rocket, you have to destroy the casing to stop the engine. So that is the working of solid rocket. Now just see, this is the fuel packed in the cylinder. So until all the fuel is exhausted, the burning continues. Burning continues. And through burning, hot gases are produced, and those hot gases are now tries to escape through the nozzle and produces a jet thrust. So with this jet thrust only produces the jet reactive force, that is the upward force. So with which the rocket is moving in the upward direction. So next, the solid propellant. What are the solid propellants? In olden days, solid propellant was gunpowder. The fuel is charcoal, and the oxidizer is a potassium nitrate. And sulfur serves as a catalyst. Nowadays, ammonium perchlorate powder used as oxidizer and combined with a fine aluminum powder, that is a fuel, is used as a solid propellant. And of course, there are so many. Just for example, I have taken two examples. And applications of solid rockets, where generally they are used. Mainly, these solid rockets are used as booster rocket motors in space applications. So the main rocket engine is usually liquid propellant rocket engine. So the booster rockets, might have observed, all of you might have observed, for the main core engine of the rocket engine, surrounding the casing, there may be 3 or 4 rocket boosters are arranged. So they are actually solid propellant rockets. First stage rocket, second stage rocket, third stage rocket. And then after first stage, then second stage comes into picture. After second stage, third stage comes into picture. Then after third stage, then the main liquid propellant rocket engine comes into picture. So that in that way, these solid propellant rocket engines are used as a booster rocket motors. They are also called rocket motors also. And these solid propellant rockets are also used in military applications. So as a rocket launcher. And they are also used in ballistic missiles, intercontinental ballistic missiles like Agni, Trishul, Nag, etc. Missiles also, these solid propellant rocket engines are used. And next, working of liquid propellant rocket engines. In liquid propellant rocket engine, the propellants, the fuel and the oxidizer are stored separately as liquids and are pumped into the combustion chamber where burning occurs. Based on the pumping mechanism, they are classified as pump feed system liquid rockets and pressure feed system liquid rockets. This is the pump feed system liquid rockets. And this is and here the fuel tank is provided, and here oxidizer tank is provided. And these are actually pumps used for supplying this fuel from fuel tank to the burning zone. This is the combustion chamber. And this pump is used to supply the oxidizer from the oxidizer tank to the combustion chamber. And here combustion takes place, and the gases are now escaped through the nozzle, and where jet thrust is produced as a reaction force. So with which the rocket is moving in the upward direction. And then pumps are actually self-operating type. Pumps need actually work input. Then how to run the pumps? With the help of a turbine. So gas turbine is used again here. So then gas turbine again needs gas. So we use a pre-burner here. In the pre-burner, we generate a gas, and that gas is expanded in the turbine, and turbine actually develops work, and with the help of the turbine work, we run the fuel pumps. These two fuel pumps. So this is a pump feed system liquid rockets. And pressure feed systems, here we are not using any pumps here. And this is the fuel tank, and this is the oxidizer tank, and this is the combustion chamber, and this is the nozzle. And here combustion takes place, and fuel is supplied, and both fuel and oxidizer are supplied to the combustion chamber with high pressure. A pressurized gas chamber is used for this purpose. So with the help of pressurized gas, then both fuel and oxidizer are sent to the combustion chamber, and here with the help of igniter, combustion takes place, and these combustible gases are now escaping through the nozzle, which produces the required thrust, jet thrust, which makes the rocket to move in the upward direction. So what are the liquid propellants? The most common liquid propellants in use today are LOX, that means liquid oxygen, and nitrogen tetroxide are some common oxidizers. And kerosene means it's not the kerosene that generally we use for domestic purpose. It is aviation kerosene. It is also called white petrol. And liquid hydrogen and hydrogen. These are some common fuels, liquid fuels. These are liquid fuels. And liquid oxygen. Oxygen usually exists in gaseous form in the normal conditions. But if you want to say liquefy the oxygen, so the temperatures should be lowered. So at low temperature only, we can actually maintain the oxygen in the liquid form. So those low temperatures are also called cryogenic temperatures. Cryogenic temperatures. One minute, please. Connection.
Sir, excuse me, sir. So time is running out, sir. Please try to wrap up,
Okay,
sir.
okay. I'm just coming to the end, sir. And then applications of liquid rockets. These are used main engines in space applications, and they are also used as main engines in the intercontinental ballistic missiles, sir. Liquid rocket engines. So that's all. Thank you, sir. Any questions, sir?
Thank you very much, sir. I request participants, if you are having any doubts, please ask, sir.
Any questions, sir?
Okay.
Shall I close,
Okay,
sir?
sir. Thank you, sir. Thank you very much, sir. Thank you for your nice
Thank you, sir.
presentation, sir.
Thanks for giving the opportunity to deliver my lecture. Thanks to all, sir.
Okay, sir. Thank you, sir. Thanks all the participants for listening this session. Thank you, one and all. So with this, we end the session.